Hi everyone! In this video, I want to dive into how you can take an Angular app or build an Angular app and connect a Node, Express, and MongoDB app to it. Now this is an excerpt from my full Udemy course, link with a great discount in the video description. It's a big excerpt though. You'll learn all the theory about how these two ends work together, Node, Express, Mongo, and Angular on the other hand, and we'll also start building this. Would obviously be awesome to welcome you in this course, but this video already should get you started with the mean stack, an awesome technology for building full stack apps with Angular on the front end. Welcome to this course. It's really great to have you on board as a student. In this course, we'll dive deeply into the mean stack. That stands for MongoDB, ExpressJS, Angular, and Node. And it means that we're going to build an Angular application, which is a client-side framework for building beautiful UIs, and also add a backend built with Node and Express and using MongoDB as a database. And therefore, you'll see the full picture of creating a full-stack Angular application. So that's really going to be amazing. And in this course, we'll cover a lot of cool features. All the basics, of course, but also things like image upload, pagination, authentication, authorization, so how to control that only users who created some content can edit or delete that content, how to deploy that on one server or on multiple servers, and so much more. Now, I'm really excited to dive into all of that together with you. The question now is, who am I? My name is Max. I'm Maximilian Schwarzmüller. I'm a freelance web developer and Udemy instructor. I got multiple 5-star rated courses here on Udemy, like my Angular The Complete Guide course, which is a great starting point before you dive into that course. And I worked with Angular and all these technologies shown in this course for a very long time. I'm so happy to share that knowledge with you, and I actually created this course 2 years ago already. I completely revamped it now in 2018 so that you're learning the latest and greatest of all these technologies. And with that, let's get started and let's dive into that. Let's start by understanding what the mean stack actually means and comprises, and let's then add all these cool features I was mentioning step by step. So what does mean stand for? What are the different components we'll learn about in this course? Mean comprises a set of 4 technologies, and this is what it stands for. The M stands for MongoDB, and it's the database we'll use in this course. So the part where we will be able to persist the data the users of our application generate, like the user data itself, but also like posts or messages they send, things like that. The E stands for Express, and ExpressJS is hard to understand without the N, so let's quickly fast forward. We also got the A, and the A stands for Angular. Now I'll come back to that N, which is related to the E, but Angular is our client-side technology. It is a JavaScript framework in the end, which we will use to render a nice dynamic UI, user interface, to our users. It runs entirely in the browser, not on the server at all, and therefore it really has just one job: presenting a nice and pleasant, interactive and reactive user interface. Now what's the N then? Well, you probably already saw that something is missing. We got a database and we got something running in the browser. But we certainly also need to run some logic on the server. For example, authenticating users. This is not something we can do in the browser because A, browser code can easily be hacked or changed, and B, it's way too complex. It would take up quite a significant amount of resources and slow down our front end, our user interface. N stands for NodeJS, and it's the JavaScript runtime, the server-side language we'll use in this course for our server-side code, so for our core business logic that runs on the server. And now the E also is related to it because whilst Node.js is the language we'll use on the server, Express is a framework for Node.js that makes working with it easier. You wouldn't need ExpressJS per se, but it makes working with it much easier. Just as Angular is a framework for JavaScript in the browser. You don't need it, but it makes things easier. But let's take a more detailed look at all these things. Now, I want to look at Angular first. As I already said, Angular runs on the client side in the browser. It's a framework building up on JavaScript or using JavaScript, and it's used to create so-called single-page applications. This essentially means that it handles the entire front-end logic. So everything your user is going to see, Angular is responsible for it. But I'll come back to it in a few seconds. Angular's job is to render the user interface with dynamic data. And that dynamic data part is important, of course. Its job is not just to render some static HTML and some CSS. We wouldn't need JavaScript for that. Its job is to update the UI. Whenever we have new information, let's say when you created a new post, we want to immediately update the UI to show that new post there. It also is responsible for handling user input, so validating that user input and also sending it to the server. Because that's the third part it does, it communicates with our backend, so with that Node Express Mongo combination that seems to be responsible for that. Angular provides a mobile app-like user experience because since we handle everything in the browser through JavaScript, we never need to reload the page. We just change parts of the page with JavaScript through Angular, and therefore everything happens instantly in a very reactive way, and that is the feeling we know from mobile apps. Now, that is still only the front end though. As I said, Node.js is the language we're going to use for the backend, so on the server side, which we also build in this course. Node.js is a server-side library, JavaScript runtime, and you know that JavaScript can run in the browser. Well, Node.js simply takes it, adds some things that are useful on the server, like working with files, working with HTTP requests, and now we can use JavaScript on the server too. Pretty amazing. Node.js listens to incoming requests and is able to send back responses. For example, our Angular app could send a request to fetch a list of all the posts, and Node could handle that request, do something, reach out to the database, and send back a response with all these posts. Node.js executes server-side logic in general, so authentication, anything we don't want to run in the browser for security or performance reasons. And Node.js is able to interact with databases and files. Angular can't do this. It doesn't have access to any file system, and especially not to a file system on some remote machine on a server. And whilst theoretically you could connect to a database from Angular, since all your client-side JavaScript code is visible to users, you can have a look at it in your developer tools of your browser, it would be very insecure to connect to your database there, because you would expose all your credentials and everything. You don't want to do that. Therefore, Node.js is an alternative to PHP, if you know that, or Ruby on Rails, ASP.NET, things like that. And it's rarely used standalone, just like these languages. You typically use a framework along with it. And that framework you typically use is Express. Express is a Node.js framework, so it still uses Node.js, the same language, but it adds a lot of utility features. So it offers additional functionalities, or in general, it makes things easier. ExpressJS is middleware-based, and we'll see what this means once we dive into the code. It basically funnels incoming requests through a chain of middlewares, of steps, where we can do something with the request, read some data from it, manipulate it, check if the user is authenticated, or basically send back a response immediately. This chain allows us to write very structured code, and you will learn everything about it in this course, of course. And last but not least, it includes routing, which means we could render views, so HTML pages with it. We're not going to do this in this course though, because Angular should handle our entire frontend. And again, this is also something we'll see. But more importantly, we can handle different requests to different endpoints, which will be important for connecting Angular to the backend. Because if we want to fetch a list of posts, we want to send some requests to /posts, so our domain /posts. If we want to create a new post, we want to send a different request to our domain /post, for example. And ExpressJS allows us to implement this routing logic so that different requests to different URLs are handled correctly. Again, this will all be implemented step by step throughout the course. So to sum it up, ExpressJS simplifies the usage of Node.js and is a tool we definitely want to use. If you have a PHP background, for example, you could compare it to Laravel for PHP. It makes things easier. There's one thing missing, and that is MongoDB, of course. MongoDB, as I already said, is a database. It's a NoSQL database, to be precise, and it stores so-called documents in so-called collections. Now, chances are you might have heard about SQL databases like MySQL, Microsoft SQL, where you have records, rows, which you store in tables. Now, NoSQL has a different logic than SQL databases. But in general, it's still a database. So you store your application data on a server so that it persists across page reloads, across the user leaving your page, things like that. So any data that is not just temporary data definitely has to be stored in such a database. Now, that NoSQL thing means that this kind of database enforces no schema, so you can have different documents with different pieces of information in the same table or collection, as it is called here, and it also doesn't really work with relations. You will see in this course that we can kind of relate different documents with each other, but in general, it's way less strict and flexible regarding relations than a SQL database is. A NoSQL database is more about storing multiple unstructured documents, though you can get some structure into it, and we will actually do that in this course. I'll come back to what exactly MongoDB is and how it works in the respective sections, no worries. Now, last but not least, it's easily connected to Node. That's pretty cool. It's very easy to integrate, or Node Express to be precise. And we don't connect it to Angular. I already said this. Theoretically, you could find a way, but you don't want to do that because you don't want to expose your database credentials in your browser side code, which can easily be viewed by the user. It's accessible in the developer tools of the browser. So, MongoDB is a powerful database which can easily be integrated into a Node Express environment, and it's very popular these days because it's very flexible and it's highly scalable. It's able to handle a large amount of throughput, so requests per second or write actions per second and read actions per second. And we'll dive deeper into this in the sections where we start working with it. Now, you could theoretically replace it with a different database. You could use a SQL database in a Node Express Angular application too. You're not limited to MongoDB, and I just want to really emphasize this. I'm using MongoDB because it's part of this popular mean stack and it has some advantages, but depending on the application and the type of data you're storing, if it's a data with a lot of relations, maybe a SQL database might be better. And whilst we will use MongoDB in this course, I just want to highlight, this is not a must. You could use any database here. The core logic we'll dive in really is the connection of Angular and Node. So with that, let me quickly come back to what exactly that single page application thing meant and how the big picture of such a mean app looks like before we start diving into our setup of the course and start building our mean app. Now, as I said, in this course, we'll build a single page application with Angular. Now, what is that? What is a single page application? Well, in an Angular app, we'll have one root HTML file, a so-called index.html file. And we will serve that from our Node server or from a different server. That's important. It can be totally decoupled of our Node backend, and it actually will be. And this HTML page basically includes some script imports that houses our Angular app. So the Angular framework and our own code. And we use that application to dynamically re-render what the user sees without ever requesting a second page to be rendered by the server. Why? Because by having this pattern, we never need to reload the page just because the user maybe clicked on a post and want to see the details. We can instead navigate to that page directly because we don't really leave the page. We just remove some elements from the DOM and add new elements. And all of that is handled for us by the Angular framework. It's really convenient to use and to work with the DOM with it. And therefore, we have a powerful way of immediately changing the page maybe showing a spinner whilst we're fetching some data behind the scenes, so that list of posts, which we probably still need to get, but we will do that behind the scenes. And this provides a highly interactive mobile app-like feeling, a very responsive and fast web page where we never have to wait, where things always happen. And that, of course, is a great user experience. And this is why we will use JavaScript and Angular, therefore, for the entire frontend, for the entire user interface. And we will use Node, Express, and MongoDB as a backend to which we reach out behind the scenes to fetch data and send data, but the whole user interface is handled as one page only, which is dynamically re-rendered all the time by Angular. With that, let's have a look at the big picture. How does the entire mean stack look like in this course, or in general, not just in this course? We have the client side and the server side. That's important. Client side is what the user sees, the web page as it runs in the browser. Server side is somewhere on a server we deploy where we run our business logic and which the user only indirectly accesses. We'll see how that access works in a second. So on the client, we use Angular, which is a JavaScript framework, so we also use JavaScript implicitly, and we use it to build that user interface. On the server side, we use Node, Express, and MongoDB. Node Express for the logic, and MongoDB as a database. As I said, you don't want to connect directly to it from Angular. Now, the client-side Angular is responsible for the user interface, so for the presentation. It's a single-page application, as I explained in the last lectures, and that single-page application can be rendered by our Node backend. So we could have one route which essentially returns that single HTML page, but it can also be totally decoupled from that and be served from a totally different host, some static host like AWS S3, for example. Now, on the Node application, we have our core business logic, especially the logic that should not be exposed to the client due to security reasons or performance reasons. We have our persistent data storage, so that database. And we also put our authentication logic there, for example. It's, of course, part of our business logic. I just want to really emphasize that here. The logic where we decide whether an email and a password is valid happens on the server, because it can easily be fiddled with on the client, not so much on the server. How do we connect the two pieces then? Well, we exchange requests and responses, and these requests and responses are sent behind the scenes, so-called AJAX requests. You might have heard of this before, and we use exactly the same pattern in Angular. These are requests which can be sent without us needing to reload the page, which is of course exactly what we want. Therefore, the type of data we exchange is not HTML, because we never want HTML code. We do all that presentation and re-rendering logic with Angular. Instead, what we get is so-called JSON data. That's a data format that's really efficient for encoding data like a list of posts. And you will see how it looks like in this course. This is the big picture. This is how the mean stack works, and this is exactly what we will implement in this course. So with that, I'd say enough of the words. Let's get started and let's start setting up the base development environment we'll work with in this course. And let's start building our mean stack application. So for this course, we will need a couple of tools, and we'll install and add them step by step. For example, MongoDB will be added a bit later. What we'll definitely need is Node.js. For one, because we will write and run Node.js code, our server-side logic, but also because even Angular needs it, even if we were not to create our own Node app, not because Angular uses Node.js language features, but because Angular actually is a framework that has a more complex build workflow. So the part where we take our source code as we write it as a developer and transform it into code that runs fine in the browser, that's a bit more complex with Angular, because Angular, for one, uses TypeScript, a superset to JavaScript, so a different language that's heavily based on JavaScript, and, that's important, that does not run in the browser. And to make it run, we need to compile it, and it will be done for us, no worries. But that task runner doing the compilation in the end is Node.js, for example. So this will run all throughout the development process. We won't need to write any code for that, but this is some stuff that happens behind the scenes. And not just the TypeScript to JavaScript compilation. The Angular code itself needs to be bundled and optimized, and we need to reduce the code size by stripping out unused code and minifying it. And all of these are tasks handled by Node.js on our machine whilst we are developing the application or when we are finishing it up, basically. And Node.js will be used for that too. So we need it for these two reasons: for the Node.js code we write for our backend, and for the Angular build workflow. And to learn more about Angular and the Angular workflow and how it works, definitely check out a course dedicated to Angular, because whilst I will cover some Angular basics in this course, in general, I do expect you to know the very basics about Angular. This is not a course for you if you never touched Angular before. So with that out of the way, download Node.js from nodejs.org, and there pick the latest version, 10.1 in my case. If you're facing issues with that, fall back to the older version, but in general, it's recommended to use 10.1 or whatever the latest version is when you're viewing this. Simply click on that and it will download an installer through which you can walk. It's available for both macOS and Windows and also Linux, and it should automatically give you the right download there. And once you successfully installed it through the installer, we can think about setting up an Angular application, because that is actually what we'll start with in this course. For that, we'll use another tool, and that's the Angular CLI. CLI stands for Command Line Interface, and it's the de facto way of creating Angular apps. Because of that more complex build workflow I mentioned, we need a lot of tools that compile our code, optimize it, and setting all of that up on our own is pretty cumbersome and error-prone. The CLI gives us a project setup where all of that is taken care of and where we can focus on writing our Angular code, our logic. The CLI is installed like this, and it uses npm, the Node Package Manager, to install the CLI tool globally on our machine with this first command here. npm, the Node Package Manager, is installed together with Node.js automatically, so if you installed Node.js, you will have npm. Now let's therefore now install the CLI. I already got Node.js installed, so I can just fast forward to this step. And to install the CLI, you should open your terminal or command prompt on your machine and then run npm, this Node Package Manager command, which is available with Node.js, install -g for globally, because we want to install that Angular CLI globally on our machine so that we can use it from anywhere on our machine. And then the name of that CLI package is @angular/CLI. And make sure to not mistype this, the naming is important. You can add a @latest to absolutely fetch the latest version, but it should by default give you that version. Now on Windows, this command should be fine like this. On Mac and Linux, you might need to add a sudo in front of this to get the right permissions to execute this command. Hit enter thereafter, and enter your password if you are prompted for it. And thereafter, it will download that CLI package from npm's repository and install it on your machine. This can take a couple of seconds up to minutes, and I'll be back once it's done. So it's done installing, and in my case, I got some errors in between, but that's no problem as long as it finishes with some output where it mentions the package name and version and says updated or added 8, or the number can actually differ, packages. So if you see something like that, it succeeded. You may ignore any errors that happened in between. It was able to recover from these. Now, once this is installed, we can create a new Angular project with the CLI. And we'll add Node and Mongo and Express to that project setup throughout the course. But let's start with the frontend, because that is how we can quickly see something on the screen. So let's create a new project. And for that, navigate into the folder where you want to create the project. Once you're in that folder, and you can get there with the cd command on your machine, create a new project with ng-new. That is a command now available due to that CLI package. ng is basically a command made available by that. And then the name of the project. And I will name it mean course, but of course you can pick any name you want. Just make sure it's not starting with a number and it's not named test. That is forbidden. But anything else is fine. Mean course should work. And once you hit enter, it will set up that project. It will create a lot of files in there. Most of them are configuration files for that workflow. We don't need to worry about them. And it will also give us a little dummy app with which we can start. It will also install all the dependencies like the Angular framework and other dependencies that framework depends on, but also a couple of build or workflow dependencies. So dependencies that compile the TypeScript code, dependencies that optimize the code, things like that. So this can take a while, and I'll be back once it's done. Now, once it is done, you can navigate into that newly created folder with cd and then the name of that folder. And in there, simply run ngserve to bring up a development-only server. And this is not a server you will use to deploy it. I will show you how to deploy that app towards the end of the course. This is a development-only server that allows you to preview your application. Double-clicking on the index.html file won't work because that will use the file protocol and not the HTTP protocol, and therefore many features we need are not enabled. And this gives us a real web server running on our machine at this address you see here, HTTP localhost 4200 by default. And you can then go to a browser and simply visit localhost 4200. And on that URL, you should see something like this, some dummy starting page the CLI gives you by default. Now with that set up, we of course want to work on our code. And for that, we need some IDE or some advanced text editor that makes that easier. Now you can use any IDE you want, like Sublime, Atom, WebStorm. In this course, I will use Visual Studio Code. Now let's set it up and open our project in the next lecture. So in the last lecture, we created our Angular application, and now we want to edit it. As I mentioned, for this we want to use an IDE or some advanced text editor because that simply makes working with our code much easier. In this course, I will use Visual Studio Code, and that code part is important, not Visual Studio, Visual Studio Code. It's a free IDE, totally free, it's pretty powerful, it's highly extensible, it's awesome. And it's available for Mac, but also for Windows, Linux. You can pick your installer version here if it doesn't auto-select the right one automatically. Simply download it then and walk through the installer it gives you. There should be nothing special about that. And once you got it installed, open it. If you open it, it should look something like this. You probably see that welcome page, and there you can click Open Folder to open that Angular project we created with the CLI a few seconds ago. If you don't see that page, you can always open it through File, Open. Now let's click Open Folder and navigate to that folder. Here I selected that main course project and I can click Open now. And this loads it into this IDE so that we can work on it there. Now, the IDE might look a bit different for you. Maybe it doesn't have this dark theme. It probably has different icons. And that is simply something I fine-tuned for myself. So I like this way of it looking and working, and I will show you how to get there. If you're using a different IDE, you of course have to fine-tune it on your own. For Visual Studio Code, I want to install a certain extension first of all, 2 extensions to be precise, and for that, go to View, Extensions. You might also see a bar on the left where you can click on Extensions icon. And on this page, make sure to install Angular Essentials. Now here I already got that installed. You can search for Angular here, and you should quickly find the Angular Essentials package. Search for Angular Essentials otherwise. And that's a pretty amazing collection of different extensions that enhance the IDE to work better with Angular. So simply install this with the Install button, and feel free to skip or read through the documentation here to find out what's included and how it works. Besides that, I use one other extension, which is purely optical. It's the Material icon theme here. So by searching for Material, you should find it. Also install this if you like the way my icons look in this course. It's purely visual, it gives you nicer file icons, and I quite like these. So with that, you can go back to View Explorer once you're done, and you should see something like this. Well, I also use a dark theme, and you can get that same look by going to that code thing here, Preferences, and their color theme. And here I'm using Dark Plus. By default, you probably are using Light Plus or Light. Now, you can try out these different themes here by simply clicking on them. You can always switch and choose the style you like. Now with that, you get the same setup as I do. Now let's get started working on our Angular app. This is the folder the Angular CLI created for us. Time to edit it. So let's quickly start working on the Angular app we created. This is the folder the CLI gave us. And as you can see, it has a bunch of subfolders and files. As I said, most of these files are purely for configuration and we don't need to worry about them. The package.json file is interesting because here you can see all the dependencies and development-only dependencies of the project. And later, once we start adding some MongoDB-related dependencies, we'll also see them here. We got files for configuring the TypeScript compilation, and you don't need to worry about that. The defaults are fine. We get the Angular JSON file, which is for the Angular CLI, and we also don't need to worry about this file in the course for now. Then E2E is for end-to-end testing. We won't cover this here. Node modules actually stores all these dependencies which are listed here, so they are installed into that folder so that they are available to the project. And you can always recreate that folder by running npm install inside this project folder in the terminal. This will read the package.json file and download and install them all into a newly created Node modules folder. And the source folder is where our Angular application lives in. Here we got even more config files, which we can safely ignore. And then we got this app folder here. Now there we write the meat of our Angular application. Angular actually uses components. I'll come back to that in the next section. And we create our whole application by composing our UI from such components. Therefore, if you have a look at that app component HTML file, you can see what we see on the screen here. This is actually the content we see here with some dynamic content here. And as I said, I won't dive deeply into all the basics of Angular, but a brief refresher will be given in the next course section. And if we change this page here, and for example, say our first app, and we save that, and ngserve is still running, that's important. It will automatically recompile and reload this page without us doing anything. But again, make sure that the ngserve process here is still up and running. You can quit it with Ctrl+C, but you should only do so once you're done with developing for the day. When you are developing, it has to run so that it watches your changes, recompiles the code, and reloads that page. And this is the front end we'll work with. We'll add more components, we'll compose a complex UI with it, and we'll start working with Angular here. Now again, I'll walk you through that project and how Angular works in a brief summary in the next section. For now, let's leave it at this little change here so that we can see that we were able to do something. Just one more word. I said that we create a single page application, and you can actually see that single page here. This index.html file in the source folder, this is the file served by ngserve right now or by your favorite host towards the end of the course. We will deploy the app together. This actually doesn't contain a lot of content. For one, because the script imports are injected by our build workflow. I said that we have quite an elaborate build workflow, and it will actually take our optimized Angular app, create the output files, and inject them in there. We don't see this during development because it happens in memory, but this is what will happen. And we see it has one HTML element in the body, and that actually is not a default HTML element. That is our custom component. You can see it here on the selector. This is how Angular works and how we take control over the UI with Angular and how we can then start composing our UI with Angular components. And now with that, I'd say let's continue and let's find out what's in this course for you before we start diving deeper into Angular and building that whole mean stack from ground. So now that we know what the mean stack is and that we have our basic project set up for this course, let's see what else is inside of this course. So we're pretty much done getting started. In the next course module, we'll dive into building the Angular frontend. You'll get an Angular refresher there too, though I also recommend diving into some dedicated Angular resources, just as for Node and Express and MongoDB if you want to learn more. But with that, we'll build the core foundation, the things we can see, or we'll at least start building these in that module. Thereafter, we'll already attach our backend, the Node Express backend, so that we can actually do more than just display a beautiful UI. Well, and we also want to work with data and want to store and fetch that data. And for that, we obviously need a database. So in the module thereafter, we'll add MongoDB to the party and therefore a really great database. I'll show you how to add it and how to work with it from Node Express and therefore also from Angular. Once we did that, we'll enhance our app. Now that's a very broad term, but we'll add some things to the Angular app, to the Node backend, to turn this into a more realistic and better app. So this will be a really important module. Thereafter, we'll already dive into image upload. That's a super interesting topic, which I was often asked about in my other courses. Here we got it. Here you will learn how to let the user select the image in your Angular app and then upload it to your Node Express server and store it there. And how to then also, of course, retrieve it. We'll thereafter have a look at another very popular topic, pagination. We get a lot of data in our database, and we typically don't want to fetch all that data in one block. That is typically not what you want to do because it impacts performance, it's more data to download. So here I will show you how you can add pagination, so how you can select chunks, slices of your data to display on a given page. And thereafter we'll dive into authentication. How can we add users, sign up, log in, and how do we store the information whether a certain user is logged in our client-side app and use it to reach protected resources on the server. Thereafter, we'll dive into something which is kind of related to authentication, authorization. Authorization is about ensuring that only users who created a post, let's say, can edit and delete that post. So we'll add this in this module. We're nearing the end of the course thereafter, and we'll dive into error handling. What does this mean and how could we elegantly handle errors in our Angular app? Once we're done with that, we're pretty much done and we'll put some optimizations into place, both on the backend and the frontend, regarding our code structure, but also regarding performance. And finally, we'll of course deploy our application, actually in two different ways, on one server and on multiple servers. And I will explain the differences in this module, of course. And with that, we're done and we'll have a complete mean app finished and deployed. And I'm very confident that once you finish this course, you'll have all the knowledge you need for your next mean project. So now that you know the structure of this course, the remaining question is, how do you get the most out of this course? Because that is honestly very important to me. Obviously, I strongly recommend watching the videos and watch them in the order I uploaded them, because with that order, I did my best to ensure that you have a great learning experience and a good learning curve. You might need to increase or reduce the playback speed for some videos or pause sometimes, because I try to go through the content of this course on an average speed. I'm not super slow and I try to not be super fast, but everyone is different when it comes to this. Some students want a slower pace, some students want a faster pace, and really use the tools the Udemy video player gives you to adjust this to your needs. Now, watching the videos is great, but I always recommend that you code along. Write the code that I teach you in this course on your own. Follow along. You will find code snapshots provided by me attached to the last lecture of every module so that you can compare your code to mine in case you're facing any errors. Because that really enhances the way you learn if you code along. And as I said, use the course resources like these attached code snippets, but also the extra links I have in the last lecture of every module to dive deeper, to solve errors, and to really become a Node Angular master. Now, finally, and that's also important, there is a Q&A section in this course. And if you got any course-related questions, so questions related to the course source code or some logical question about some concept I taught here, please post them there. I do read and reply there regularly. Now, asking is great, but often you can solve issues on your own by Googling, by comparing code. And you can also help other students. If you see open questions, please also reply there. It can be hard to do that because you're afraid that your answer might be wrong, but who cares? Even if it's wrong, then you'll learn again because someone is going to correct you. I really want you to interact because by answering, you will learn the most. Asking is easy, answering is much harder, and it challenges you to think about a problem, to come up with a solution. And if you want to become a true master, definitely dive into questions and answer them. That will really help you the most, I promise. And that is how you should get the most out of the course and really, well, become a great Angular Node developer by the end of it. Welcome to this module. Now that we're all set up and learned how we set up our IDE and create our first Angular experience, let's dive into our course project. Now you will learn how the mean stack works on a real project. We'll build a simple posting messaging-like app where users can create and edit and delete posts and see the posts of other users, which they can't edit though. So a mini social network, we could say. This is what we built, and we'll actually start with the Angular frontend. So if we have a look at our big picture here on how the mean stack works, we're going to focus on the left side here, on the client side. And the reason for this simply is that by doing that, we can see something very quickly. The backend holds a lot of logic, but we don't see that much of that if we don't have a front end where we can actually render our data and display it. So we'll start with the left part because we can always work with some dummy data until we have the real backend added, but we get a beautiful UI right from the start. So this is what we'll start with in this module. And I will also give you a brief reintroduction to Angular. Now, I strongly recommend going through a dedicated Angular course first. This is not a course that teaches you Angular from the ground up, but I will cover the important basics and briefly refresh them so that we're all on the same page. Now with that, let's jump right into it. Let's create a new Angular project and let's start building our course project with it. I'm back in that first Angular app we created in the first course module. There, we haven't changed that much, just added this line in the app component, and now I will build up on that project and use it for our mean project. Now, first of all, let's understand this folder structure a bit better, and let's understand how an Angular application actually starts. For that, I need to start it, so I'll bring up my terminal, integrate it into my IDE here, and run ngserve to start that build process, which we should keep on running, and which also starts this development server where we can preview our Angular application. Here it is. Not that spectacular, to be honest, but we'll add a lot more to it very soon. Now, to understand how it starts, let's have a look at its source code actually. And if we inspect that source code, what we can see is that we don't see a lot, do we? We got a basic HTML5 skeleton, and then we got a bunch of script imports at the bottom. That clearly is important, but that's roughly it. There's no content on this page. And yes, our page doesn't have that much content on it. It's only our first app, but at least this text should be visible, right? But we don't see that text here. Instead, we just have app root here. And this is an important thing. This is not a default HTML tag or element. This clearly has to be related to our Angular application, as do all these script imports down there. And that's exactly what's happening. If we go back to our application, we can clearly see that what we see on the page is the content of the app component HTML file. And that really is important because Angular thinks in components, and what we do here is we build our own components, or you could say our own HTML elements. What we loaded, the page we loaded, actually was this index.html file, and there we see that app root, right? We covered that before. Now, the script imports are missing here because they're injected, but it's this app root element that is loaded, and as you already learned, this is our own component. Here is the selector, our own HTML tag we assign, so to say. So this is how this is roughly connected. And the CLI in this build process, which we have up and running, takes our code, bundles it up, adds all the Angular logic from the Angular framework to it, and therefore creates a bunch of script files, which we don't see here because it's loaded in memory for development, and injects these script file imports into the index.html file. And what's happening there in the end is that this actually then detects this app root element and swaps it with the content of our component. And content is not just the visual part, the HTML part, it would also be any logic we have here. And we will add a lot of logic throughout this course, of course. So this is how we connect these two things. But where is this swapping logic defined? Where do we tell the browser that this is our own tag, so to say? Well, we get two other important files for that. The app module is one important file. This essentially is a file which is important for Angular. It defines the features our Angular application has, because Angular thinks in applications, and applications are split up in modules, or in this case in one module, and that module defines the building blocks of our application. And components are not the only, but probably the most important building block of an Angular application. And what we're doing here in this app module is we're declaring the app component. This is registering it with Angular, so now Angular is aware of the app component. But this alone would only allow us to use that component selector in other Angular components, not in the index.html file. This is allowed by adding it to the bootstrap array too. And we typically only have one component in there because we only have one root component in a typical Angular application, and all other components would be somehow nested in that root component. And this is also how we will build our application in this course. So we get that bootstrap array, which essentially tells Angular that it should search the index.html file, which is loaded, or in general, the page in which the Angular app is loaded, for the app component identified by its selector. Now, the only remaining thing is what actually starts the Angular application, and that is the content of the main.ts file. This is executed first, and that is simply how it's defined. You don't define that. This is what Angular does, or how the CLI packages up our files in the end. The code in here will execute first, and what we're doing here mainly is executing this line. We import a bunch of stuff because for TypeScript to use a certain feature in a file, we need to import it so that TypeScript knows where the code for that feature is located. And then we have this line here, which uses an Angular feature, platform browser dynamic. That's a function. We execute that. It essentially starts the Angular application in the browser, and Angular is a browser-side framework, so that seems to be important. And then we call another function on an object. This first function seems to return, and that's the bootstrap module function. And there we pass a link to our own module, the app module, which is located in the app module file. We pass this as an argument, and this essentially tells Angular, start your Angular application and start it with this module in mind. So now Angular parses this module, so to say, registers these components which are declared, imports some other modules, because there are some modules Angular ships with, like the browser module, which contains some core features of the Angular framework. And last but not least, it detects the bootstrap array, and it then looks on the page it's running on for the selector of this component. And this is how the Angular application starts, how it detects the building blocks that make up that application, and how we in the end see our first app on the screen because we use our own component, which is understood and used by the Angular framework. I already mentioned that Angular thinks in components, that components are one of these crucial things you have to understand when working with Angular. Essentially, you compose an entire page of these components. You build it with these components, because the advantage of this is that you have small, easily to maintain and manage building blocks for your UI, which you can even reuse, because some components appear more than once on a page. Now, here's a screenshot from the official Angular.io page, and we can easily deconstruct this into different components to understand this way of thinking in components. We could think of having a header, a brand, and some feature component. So 3 sections of the page, which are kind of independent from each other and which we can define in their own components so that we can easily manage the code for that given part of the page. But we can and we should be even more granular than that. We can clearly identify some navigation items in the header and our search. And even in the navigation items, we could argue that each navigation item on its own is its own component. Now, you can, of course, go as granular as you want. It probably doesn't make sense to wrap a single HTML element into its own component, at least in most cases. But if you got a certain part of your UI that really is decoupled from other elements on the UI, and that probably also contains some logic, like the search here. It definitely has some logic like type ahead or filtering or showing some preview. So if you got that, then you want to put it into its own component so that you can easily manage the code and possibly reuse it. That search could be used in other parts of the application too. And we can also do that here for the bottom of this screenshot. In the feature component, now this could be all in one component, but maybe we even split that up a bit more because we might want to reuse that image. Maybe it contains some logic for lazy loading the image, and we want to use that on other parts of the page too. So as you can see, you can go very granular, and you probably already knew that if you worked with Angular before, and we will go granular in this course too. We will build our mean stack application, the front end of it. We will build that with a lot of Angular components. So let's get started writing some code and let's dive into that component world. In this course, we'll build an application where users can create posts, can read the posts of other users, edit their own ones, and so on. So let's start working on that. And we certainly don't want to handle all that logic in one component only, because that would quickly explode in size. Theoretically, it would be possible though. That's important to understand. But I want to create more than one component. And we can simply create a new component by going to that app folder. This is where you manage your Angular app and the parts that make up that app. And by adding a new subfolder there, you typically put new components or blocks of components into subfolders to keep your code organized. Now in there, I'll create a new component for creating a new post, because that sounds like a good start. If we want to work with posts, we need to be able to create them. Otherwise, reading them will be hard. So I will create a new posts subfolder here, which should hold all my post-related components. And since each component typically is made up of more than one file, we got a template for the HTML code and a CSS file for the styling, as well as the TypeScript file for the logic. I'll create yet another subfolder in there to organize the files of a single component in there. Now this is up to you. You could also use a flatter folder structure where you don't use that many subfolders. I'll go the subfolder way here. So in here, I want to be able to create a new post, and I'll name this post-create because I'll create the post-create component in there. The file which I create in there is the post-create.component.ts file. And now the file name theoretically is up to you, but it's a convention in Angular to include .component in component files, or in general, include a description of what's in the file name with this dot notation as we do here. .ts is the extension because we use TypeScript, and the part in front of that, there you typically use the kebab case, so dash separated words, for describing which kind of component this is. Now I got that post create component in there, but a component, as I said, typically is more than just the logic. It at least needs a template. Now theoretically, you can also define that HTML template in this TypeScript file, but since we have a bit of a more complex template, and in general, it's a good practice to create a separate file. So that will be the post create.component.html file now. So that's the HTML file belonging to that component. And with these two files, we can work with that. Now in the TypeScript file, we create a component by simply creating a new class. A class is a TypeScript feature. It's also available in the latest JavaScript versions. It essentially allows us to create a blueprint for an object, though we will never create that component object on our own. We just give it to Angular, and Angular will instantiate it and create it and use it. We just define how such a component would look like. And that includes a name for it. There, the convention is to use basically your file name, but now in that notation here, post create component. So the individual words starting with capital characters and component at the end. And we actually, as I said, create a class here, so don't forget the class keyword. And now we get a new class, which essentially is just a TypeScript class. We turn it into a component Angular understands by adding a so-called decorator to it. A decorator is a TypeScript feature. You add an and then the name of the decorator, and Angular ships with a component decorator. To use it in that file, you need to import it though. So import component from @Angular core. Now this is one of the packages the Angular framework is comprised of, and this package includes these core features like that component decorator, which you attach to a class to mark it as a component, which Angular then scans for certain features and uses as a component. Now the component decorator takes some configuration in the form of a JavaScript object which we pass to it. In that object we need to define things like the template. So we define a template, and if we just use template, you could pass a string in here to write some HTML code here. But for longer templates, this is not really something you want to do. Define a template URL instead, and then add a relative path to your template file. So in my case, it's post create.component.html. So this is then the file Angular will look for the template and then parse. So now this is pointing at that HTML file. Now with that, we also need to add more. We want to add a selector. Let's actually add that first. A selector which allows us to use that component. So to use it by that selector, which serves as our own HTML tag. The convention is to start with app dash to avoid clashes with normal HTML elements, which name you might take otherwise accidentally. And then any name you want, but typically you also use the, file name or the component name for this. So app post create. Don't forget the comma. Now this defines a basic component. You need a template, and you typically also need a selector so that you're able to include it. You don't need to add anything in the TypeScript code here. We want to add something in the template so that we can see it. Maybe a h2 tag, the post create component. And now what? Now we could use it. We could go to the app component HTML file, because remember, all components other than the app component are added to other Angular components, not the index.html file. And in the app component HTML file, we could add app post create like that. This is now our own HTML tag, our own component being used. You see my IDE already isn't liking this. And if we save that and we go back to the application, we see a blank screen. If we now open the developer tools here in the browser, we see that we got an error message that app post create is not a known element. And the reason for that is that it isn't a known element. Angular has no way of knowing this because by default, Angular, and also not the build process, it doesn't scan all files in our app folder and try to evaluate if it should be aware of that, if that is a component. Instead, we explicitly have to register a component if we want to use it, and we do that in an Angular module, in the only module we got thus far, in the app module. There, we add it to declarations. And for that, we first of all need to import it. That's a TypeScript requirement. If you use something in another file, you need to tell TypeScript where the code behind it can be found. So we want to import something from posts/postcreate/postcreate component, and you omit the extension, so you don't add .ts here. Now the something we want to import is the postcreate component class, so a reference to that class to be precise. And we store that in the declarations array here, so that now Angular is aware of this. And that is all we need to do. Now if we save that, you see the post create component here. And the errors in the IDE will also go away as soon as you change something in the respective files and then save again. So now we got our first component added. That's nice. It's not that useful though. Would be nice if we could use that component to really, well, create new posts. So let's do that in the next lecture. We want to create new posts, and we got that post create component. Thus far, it only got a title. Well, what do we need to create new posts? As a core minimum, we need an input and we need a button to save that post, right? So let's add both in the template of post create. An input, a normal text input, or maybe a text area, because we want to be able to enter more text than just one line. So let's add a text area. Now, we don't need a name. We can omit the ID. Colons, we don't need that. Rows, I'll set this to 6 so that's a bit smaller. And if we save that, we see a text area. No styles, so it's not that pretty. We'll come back to the styling soon. Let's focus on the logic for now. As I said, we also need a button, so let's add a button below the text area where we say save post, like that. And now, of course, this doesn't do anything. It looks super ugly. Let's actually do something about that. Let's add a horizontal line between the two for now. But it's still not pretty. But we can work with that. So we can click that button, but it doesn't do anything. We can enter anything here, but that, of course, doesn't create a new post because what's missing? The logic. Well, also the styling, but mainly the logic. How would the browser know what we want to do when we click Save Post? It can't. And that is exactly the logic we'll add with Angular. Now, to do something, upon a click here, we need to add a click listener. And we do that with a feature called event binding. Event binding is an Angular feature which allows us to listen to events in a declarative way, which means instead of using JavaScript, where we would go to our code and then try to select the element with query selector or anything like that, and then use add event listener on the element, instead of doing all that programmatically, we go to our template and we add something there, which is not default HTML, but which is understood by Angular, since this is an Angular component. We add parentheses, and in between there, the name of the event we want to listen to. And that's now not on click, but just click. So the name without on. And you can, of course, also listen to things like mouse down, mouse enter, and so on. But here it's click, then equal, and then quotation marks, between which you define the code you want to execute. Now, that can't be complex code here in the template, and typically you just pass the name of a method of that component class here, which should be executed. So we could add a method, that's a function in a class, to that post create component, and I'll simply name it onAddPost. The name is up to you, but you typically start with an on at the beginning of your method name for methods that are triggered upon events. Now in there, we want to get information about that new post, right? And for now, what I'll do is I'll just throw an alert, post added, so that we can see if that worked, if we successfully triggered this. Now, I pass this onAddPost function name here, including the parentheses, to click. And what this will do is it will connect both. After reloading for click save post, we see that alert appear. So that worked. Now, that's the first step. We are able to listen to events. We're not able to get the input we entered here, and we're not able to output anything on the screen other than that alert. These are the things we'll work on next. So before we come to fetching that user input, let's output a post. Let's output some dummy content. Let's say we have a paragraph there below the button, and here we want to output the content the user entered. Now for now, the user didn't enter anything, so let's set some dummy content. For this, we need two things. We need to set some content in onAddPost, and we need a place to store that content in, which we then can also refer to from the template. That store the content in thing is a property, basically a variable in a class. You define it without the var, const, or let keyword. You just add the name in the class here, and the name can be anything you like for example, new post. Now, I'll set this to an empty string by default, and then on add post, I will override it. We refer to it with the this keyword, this new post, and we set this equal to any content you like the user's, oops, escape that, post, like that. Notice that I escaped that in between single quotation mark with a backslash. So now we're setting the new post value to this value whenever we click the button. Now to output the new post, we need to go back to the HTML file. And just as we added the listener directly in here, we also add output or output hooks directly in the template. We do that with a feature called string interpolation. And you add or use that feature with double curly braces, opening and closing. And in between, you refer to something which is stored inside your post create component or your component belonging to the template in general. That something could be a method, and then you would output whatever this method returns. Or it can be a property name, like new post. So here I can just say new post and refer to that property. And now what you can see is that when I save this, you don't see anything because we start with an empty string in new post. But if I click save post, you see the user's post here because we changed that text. And due to string interpolation, we told Angular, hey, please output the current value of the text. And also when it changes, please output the new value in this place here in our HTML code. So that is string interpolation in place. And that is one important building block when it comes to outputting content. Now, let's also dive into one other way of outputting content on the screen. Let's say we want to pre-populate the text area with some dummy starting text. Let's say we don't start with an empty string here, but with no content. Now, of course, if I save this, it reloads and we have no content here until we click the button. And let's say we want to output no content in the text area too. Now, in the text area, we can use string interpolation like this, new post. And if we save that, we get no content in there too. We could also do something different. A text area is your input element in HTML, and as such, it has a special property we can bind to. Not an attribute, a property. HTML elements in the DOM and in JavaScript are just JavaScript objects with a couple of properties, so variables belonging to that object, which we can read and write. And one property is the value property. Now, the value property actually can't be set like this. So if we set this to test here, you see it's empty. But we have another feature in Angular which allows us to directly target properties of the underlying objects of the HTML elements. We can add the property name, and of course you have to know that this element has a value property, but now you do know. You can use resources like the MDN, the Mozilla Developer Network, to get complete references of all available properties of all available elements. But if you know that name, you can wrap it in square brackets like this. And this will now directly target the value property of the underlying object and bind the value between quotation marks to it. Now important, just as for the click listener or for string interpolation, this value is now not normal text, but actually TypeScript code. So if you enter test here, it would look for a property named test in your component. If you want to output test as a string, you need to wrap this in single quotation marks. And now if you save this, you see test as a starting value because we're binding to the underlying value property. And of course, you can also bind this not to a string, but to new post. Now without the single quotation marks, because now we want to refer to that property in our component class, and now we see no content there too. This is important to know. We will use a combination of string interpolation for simple text, most of the time if you want to output it between opening and closing tags, and property binding, always used directly on the elements, for outputting data in our template. Now we can output data, that's all cool, but how can we now finally get that user input? We'll do this in the next lecture. So let's get the user input, and there actually are two ways of doing that. The first one is another feature which is called local reference. We can add a marker, a variable, to any HTML element we want. We do that by adding a hashtag and then any name you want, like post input, like that. Now this marks this, or it creates a reference to that element which you can use, and that's important, in that template. So you can use it, for example, here to pass data to onAddPost. You could refer to post input like this, without the hashtag now, and then pass this entire thing. So this will now just be a reference to the underlying JavaScript object. In onAddPost, we can take a look at it by expecting it as an argument. So there we get the post input, and this will actually be an HTML input. We can clearly tell TypeScript the type by adding a colon, then HTML text area element. That is exactly what it is. Now this just informs TypeScript about the type here. This is great because now we get better auto-completion because the IDE knows which kind of type that is, but it also helps us write cleaner code. But I, of course, only want to do one thing here. I want to output the post input like this. If we save that and let it reload and have the developer tools open, we see that upon saving, I get this output. Now, we can't really see what's in there. We can't really see the JavaScript object. We can look into that with console.dir instead of console.log. Now, if we press Save Content, we get the text area object, and here you see all the properties this specific JavaScript object knows. Quite a lot, as you can see. There also is the value property we bound before. Now, of course, we cannot just bind the value property. Since we got access to it here, we can also just use it to extract the content and set the content we entered as a value for new post. So we can say post input.value to access that value property. And now if we save that, what we can see is that if we enter something here and I hit save post, we see something down there. Now that really is amazing, and this allows us to fetch the user input and output it. It's only one way of getting that user input though. This is a way which of course allows us to do anything with that element, not just get the value, but then get the value, if that is what we want to do, upon a click. Now another feature Angular offers is a feature called two-way binding. Rather than manually setting the value of the text area and then also getting a reference to it and so on, we can get rid of both and actually add a new feature which combines the setting and reading of a value. It's called two-way binding because it has this two-directional flow, and you add it with square brackets and parentheses, and then ngModel in between. ngModel is an Angular feature. It's a so-called directive. A directive is basically an instruction you place on an HTML element in Angular, or you can also create your own ones, so the directive knows what to do on that element then. ngModel is a directive that actually will listen to user input and emit that data to us, and also store new data in that text area, or output it there. We need to bind it to a property, and I will use a new property for that, because I don't want to update new post with every keystroke. I'll add entered value here, and it's an empty string initially. And entered value, this new property, is what I bind to ngModel. Now important, ngModel by default won't work. It's a feature which is not included in the core Angular package here. It's not included in the browser module, which we already added. It's included in a different module, which we need to add. It's included in the so-called forms module, because it's related to forms inputs. And this is part of add Angular forms. So that's still part of the core framework, but of a different part of the framework. So importing it here allows TypeScript to find it. Angular isn't aware of it yet though. It is aware once we add it to the imports array in our app module. Now we're unlocking some forms features, and ngModel is one of them. So now we can use ngModel here, and it will automatically update enter value or entered value here with every keystroke. And therefore, in this new post, we no longer receive the post input here. Instead, we simply set new post equal to entered value, this entered value. Back in the template, this also means we get rid of post input as an argument here. And now if we save that and we go back to our application, you see we don't start with no content anymore. I can enter something, and if I hit save post, we see that here too, but now we're using that two-way binding feature, which can also be very handy. These are the core template binding features Angular has. Event binding, string interpolation, property binding, which you saw it before with square brackets value, and two-way binding. With that, we got a lot of tools that allow us to manipulate our components and the output we have, and also to react to user events. And now with that, it's time to leave that world of ugly applications and actually turn this into a pretty one and dive deeper into really building a mean stack project, because this is of course no Angular basics course, but knowing all these basics and refreshing them is really important so that you don't get lost throughout the rest of the course. So now that we had this brief refresher on the very basics of Angular, it's time to work on the real application we're building, and we want to build a beautiful application, right? Now we could write all these CSS styles on our own and write everything from scratch on our own, but this is an Angular or especially a mean stack guide, and I want to focus on these mean stack components and not so much on the styling. Therefore, I'll use Angular Material, which is a package actually also created by parts of the Angular team, which gives us a set of pre-built Angular components. And that's important. It's not just a styling package. It's not like Bootstrap. It's actually an Angular package which ships with a couple of Angular components which we can drop into our application. Now we'll still write all the core logic of our application on our own, but all the nitty-gritty details and, to be honest, quite a lot of the styling will be taken care of. Now this uses Google's material design, so of course you have to like that to be happy with that. But I think it looks quite nice, and if we have a look at the components part on material.angular.io, we can see it has a bunch of pre-built components that should give us everything we need to build a nice application, to include things like a header, include things like our buttons, our inputs, things like that. So this is what I want to work with. And to add it to our project, I'll quit my development server for now. And I need to install this. So we'll run npm install --save. This will install a new dependency into that project. npm is that package manager. And now it's @angular/material. Now don't hit enter yet. This is one way of adding it. Now if you're using the latest CLI version, which you very likely are, CLI version 6+ to be precise, then you got a different command available. And if you don't use that latest version, you can always update by running npm install -g @angular CLI, by the way. So if you use that latest version and your project was created with that latest version too, you can run ng add, now that's a CLI command, @angular material. And what this will do is it will also install the material package, but also already configure your project to include it. And I'll of course show you what this means, what included actually means. And by the way, I also got a series on YouTube and my webpage, which you can check out. You'll find a link to it in the last lecture of this module, where I give a little bit of a more detailed walkthrough of Angular Material. I also got another course here on Udemy where I dive deeper into it. In this course, this will not be an Angular Material course. I just want to use it, and I will therefore just explain the basics you need to know about using it. So now it's done setting it up, and what it did is, in the package.json file, it added a new dependency, or two new dependencies to be precise, Angular Material, this package, and the Angular CDK. Now, the material package actually is split up in two packages, you could say, one for the logic behind the components and one for the concrete implementations and the styling. The CDK is the logic, material is then logic plus styling, and more on that in that series I just mentioned. This is included, this is installed as a dependency. In the Angular JSON file, which configures our project, it also did one thing. It added this input here, this style here, which simply includes a default theme of the material design package. Indigo pink, so that's just some colors. That's the styling for all these components. And you can actually switch that with another pre-built theme. You can see all of them in Node modules, add Angular, and then there search for material here. And then in material, you should find a folder, pre-built themes, this one. And there you see 4 files, indigo pink, deep purple amber, and so on. Now we're using indigo pink here, and you can always switch this. So you can also use purple green, deep purple amber. I'll stick to this one, but you can switch this with one of the other files. So this is the styling that is added. Now what else did the ng add command do for us? It added our app module. There, it now imports the browser animations module, a part of the Angular framework, because some of these components provided by Angular material use animations, and therefore this is included too. And that's basically it. You can also see a log of what it did here. So it updated package.json, AngularJSON, app module, styled CSS. Now also the index.html file. There we can see what it did is it included imports to the material icons so that we can use these icons, and the Roboto font so that our text actually has the normal material design too. So that is what now happened. Now we can restart ng-serve and we can start using Angular material. And to use it, we actually just need to import what we need and use the component in our template. So first of all, let's start by pimping that post create component. And for that, let's look at form controls in the official docs. That sounds promising. And what we need is some input, right? We need some inputs. We want to be able to add a text area. So we got our input and text area elements, which you can use. And here, if we check out that example code, we can also see how such an input is created with the Angular material package. Essentially, we add this mat input thing to an input element. We can ignore that form thing for now. So let's go back to our project. And to use such an input element, we need to unlock it, because by default, none of the components provided by Angular material is available in our application. And this is done to save space, that our final application is as small as possible and we don't import things which we don't use. Now I want to use something, of course. So let's actually move that import here up to the top to keep all the Angular imports in one place. And then let's import something from @Angular material. And that something I want to import here is just a module. It's the mat input module. And we can take that module and add it to the imports array. And what this does is it unlocks all the input related components. So now we can go back to the post create component HTML file. And there, the text area, we simply add mat input to it. This is the selector which turns this into an Angular material input. Now let's save this. And I don't see a big difference, do you? Now, the reason why we don't see a difference is that actually all these input components only work in conjunction with another, component we have to add as a wrapper. And that's the mat form field component. Now that's just another component provided by Angular material, and we put our inputs in there. Now I said we don't have to worry about that form thing, and we won't use a form yet, but this is something we need to add to get a styling that looks better. So now we can see Angular material seems to do something. We don't have that ugly input from before. Now it's also not super pretty yet, but we'll get there. To turn this into a prettier component, what I'll do is I'll use another component from the Angular material framework, and that's the mat card. So let's add another import in the app module, mat card module. Card is a special container, a look you will probably know from other pages. Let's add the mat card module to the imports array. And then in the post create component, I'll wrap my mat form field here with mat-card. Now this creates such a card look. If I put it in there and we save that, you will see now it's indented a bit more and you see there's a slight shadow below that. Now we can't see it that well because it's a bit hard to see. It's taking up all the width. So let's restrict that width by also adding some custom styles to that. We can still do that. I'll add a new file, post create component.css for the styling for this component. And we need to import this by going to the TypeScript file of the component and adding style URLs here. Now that's an array of external style sheets. We can only have one template, but we can have multiple styles. And there I point at post create component.css. Now we can write our own CSS code there. And I will target my mat card element. That's cool. We can use the Angular selectors here as style targets. So I will target mat card here and actually restrict the width to, let's say, 80% and add margin auto to center this. Now if we save that, now we can see the card here a bit better and we got our form field in there. And if we type, you see this is our form field. Now this is taking shape. Now, I'm still not perfectly happy with that. I also want to change the look of my text area a bit more. So I'll also target my text area in that component. And the cool thing is, these styles will be scoped to this component. So even if we use a text area or a mat card in another component, these styles will not apply to it. It will just apply the styles to the elements in this component. So I'll take my text area and set the width of it to 100% here actually. However, for this to have an effect, I also need to take the wrapping element, mat foreign field, and give that a width of 100%. And now if we save that, you see the input is spanning the entire width here. And now I want to put my button into the card too. So I'll take that button, put it below that mat foreign field, remove the HR tag here, and of course it would be nice if the button would look prettier too. So we can turn it into a material design button by including one more thing from the Angular material package, the mat button module here, and I will add this down there, mat button module. So now we're including the mat button module, and now we can go back to our HTML code and turn this into a nice looking button by adding mat button or mat raised button to get this raised button look. And you can find out which values you can use, of course, in the Angular material docs. In case you want to dive deeper, you can always dive into the docs, read through them, check the API documentation for a full list of the features you can configure, things like that. So now this is the button. Now it would be nicer if it had some color, and thankfully, if you check out the docs, you find out that you can add a color property. I'm just splitting this over multiple lines to make it easier to read. So here I will add color, and you can set this to primary or accent or warn. Now warn is some warning color. Red, don't want to do that. I want to use my primary color. Whoops, primary. And now this will use the indigo color in this case because I'm using the indigo pink theme. You can of course also use accent, and maybe I actually prefer this. I think it's even clearer to see. So now we get the button, we get the input here. Now this is looking prettier. Now it's time to add a toolbar and then also add a real posts management, because right now we're not really adding new posts, we're just overwriting some text which we output. Time to change that. Let's start with the toolbar, because I think every application has some sort of header, and I'll actually create a new component for that. So not on the posts folder, but in the app folder itself, I'll add a new folder, header, and in there I want to create my own header component. So I'll name it header.component.ts and add a header.component.html file. You learned how we create these components, so I'll go through that a bit quicker. Export my class header component in there, and add the add component decorator, which you need to import from @Angular core. My IDE automatically added the import. You might need to do that manually depending on your IDE. Add a selector. I'll name it app header, and then also add a template or a template URL. And here I'll be pointing to my header.component.html file. Now that's the header component TypeScript file. In the HTML file, I will use yet another component provided by the Angular Material framework. So in app module, we need to unlock that first. Here to our import list from add Angular material, I'll import yet another module, the mat toolbar module. Now, as you probably can guess, this unlocks a certain toolbar component. To unlock it for Angular, we need to add this to our imports array. And now we can use the material design toolbar. Let's quickly check out the docs. There on the left, you find toolbar. And you can check out the demo code. As you can see, it's really easy to use, not that difficult. You can configure a lot though. Again, feel free to read through the entire documentation here. So I will add it in my header component, toolbar. And we can, for example, set a color, which I will set to primary because I don't like that boring grayish look. And there, for now, I'll just set my messages as a title, so to say. Now, the header component isn't used yet. To use it, we first of all need to unlock it. So we go to declarations in our app module, not imports, because we're not importing another module. We're just importing another component in our case. And there I will add my own component. So I'll again let my IDE automatically import this, and I will just add header component, and my IDE adds the import up here. This is important. So now this is added. Now we can use the header component here. And I want to use it in my app component. Instead of our first app, I'll add app header like this. Now with that added here, let's save this. Let's go back to our application, and we get this nice toolbar above the rest of our application. Now the card is sitting directly on the edge of the toolbar. To change this, what we can do is we can simply wrap our main content with the main element. Now that's a normal HTML element. Put our post create component in there. And now style that main element directly here in the app component CSS file maybe. And you can, of course, also use CSS class selectors. You don't have to always select the elements. So here I will give this some margin to the top of, let's say, 1 rem or 16 pixels would be the equivalent. Whichever unit you prefer, I will work with rems here. So now we get some distance between the card and the toolbar. Now, the thing that is missing for now, we'll add navigation later, the thing that is missing for now is a way to output the posts. It would be nice to output the posts below our input area here. So let's do this next. So the goal is to be able to output the posts, and for this I'll add another new component. Because I said you want to be granular, and creating a post is actually something which is decoupled from outputting the posts. So in the post folder, I'll create a new subfolder, which I'll name post list, and in there I'll add my post-list.component.ts file and the post-list.component.html file for the HTML content. Now, you know how to create such a component. By the way, if you use the CLI regularly for that, you can also create components with the CLI with a command. I'm a fan of the manual approach, also because it's really good for practicing. So here I'll export another class, post list component. And as you know, we add the add component decorator to it. And in there, we add a selector. This will be app post list, and a template URL link where we point to our post list component.html file. So now we got that base component set up. As you know, we need to include it to app module to use it. So in the declarations array, I'll add my post list component, also add the import. Here my IDE added it. And with that, we can use it in the app component, maybe below the app post create component. There we could add app post list like this. Now, right now our component is empty. The goal is to render a list of posts in there. So for now, first of all, let's go back to post create component and get rid of that ugly paragraph, and then dive into the post list component HTML template. I want to use another feature of the Angular material package, and that can be found under layout. I want to use the expansion panel, which is a collapsible panel where we can display some content. Now, to use this, I'll go back to the app module, and import one additional module from Angular material, the mat expansion module, and also add this to the imports array here, mat expansion module, like this. And now with that added, let's go back to the post list component HTML file. And to use it, we can again have a look at the official docs, at the dummy source code there. As you can see, they use the mat accordion to wrap this all. This is used to basically be able to orchestrate all these expansion panels. Now we can easily recreate this by adding mat accordion here as an element in our post list component HTML file. And in there, add the mat expansion panel element. And in that mat expansion panel element, you can have a mat expansion panel header. This allows you to define a title. And below that header, you can also have some regular content. Like here, I'm in an expansion panel, like this. And this would be the expansion title. Now, if we save that and we go back to our application, we can see our expandable element here. Now, it's sitting directly beneath the card at the top here, which is not super pretty. Additionally, I'd also like to restrict the width of that. Since I want to restrict the width of both the input and this, maybe I want to restrict the width of the total main content. So let's go actually to the post create component, to the style there, and I will not set mat card here anymore to have a width of 80%. Instead, I go to my app component CSS file, and for the main area here, there I will set a width of 80% and margin auto for now. So now both is limited in width and centered. Now to have some spacing between our post list component and our post create component, we got multiple ways of achieving this. One simple way is to add a margin top to our post list component, and we can do this by adding post list component.css here and import this into our post list component by adding style URLs here, post list component.css. And in here, then target a special selector, the host selector, which targets the element itself, so to say, and add a margin top of 1 rem. And if we save that, nothing changed because actually all the elements by default are not treated as block level elements. So we have to set display to block first. Once we do that, now we get some spacing here. Cool. So now this is working. Now let's go back to populating this with some content too. We got a title and a, content. So we might want to add a new field for a title here eventually. But first of all, let's see how we could output a list of some dummy posts. So back in the post list component, we only got one expansion panel with hard-coded content in there. Now let's say we had a list of posts. So the post list component, let's say we have posts. And this actually is an array. And in there we got some JavaScript object where every post has a title like first post and some content like this is the first post's content. And we had not just one, but 3 posts. So the second and the third post. And here we got the second post and the third post content. Now it would be nice if we could dynamically loop through all these posts and output that data in our template, right? Now, actually Angular has us covered when it comes to this. It offers so-called directives, which I already mentioned before briefly, which allow us to manipulate elements in the DOM when needed. Now let's dive deeper into what I mean with this and how this works in the next lecture. In the last lecture, we added our expansion panels, and now we got some data here. And that's a typical use case, right? It is also what we will have at the end of this course. You fetch data from some backend, from some server, a list of posts, a list of users, whatever it is, and you want to output this in your template. Therefore, you don't know in advance how many elements you're going to need. We only got one expansion panel, now we would need 3. And we don't want to hard code our content in there anyways. So we need some way of dynamically looping through that code and creating as many panels as required. And we can do that with the help of a so-called structural directive. Angular ships with directives, which, as I mentioned before, are instructions you place on an element. And there are some instructions that only apply to a single element. ngModel was one of them. But there also are instructions which structurally change the rendered HTML code. And that's the case here. We can use another special directive, ng4, and you add it with star ng4. The casing and the star is important. And this is essentially a helper tool that allows you to repeat an element as often as required. Now, the as often as required part is defined here between the quotation marks after the equal sign. Here, you write the looping logic like this. You add let to create a variable, let post in our case, this name is totally up to you, of, and then the data you want to loop through. So here, it's this post's name. So this is not up to you, or it's up to you, but you have to change it here and in the component if you change it. And now we're looping through all the posts, and we're storing the individual post in this post variable, which is created here. And now the cool thing is, we can use that variable in the template here. We can output post title here, for example, and down there, we can output post content like that. And now it will create as many expansion panels as we need and give us access to the data we're looking at. And now if we save this, we get 3 expansion panels for the different posts. And you see by default only one of them can be opened. If you want to allow multiple ones, you can add multi and set this to true on the accordion. Now you would also be able to expand more than one post at a time. So this is now our accordion with the posts, and this is how we can render data, a list of data dynamically with the help of ng4. Now, of course, we don't want to use hard-coded data. We want to use data which we actually receive from, well, the post create component in our case here. And to do that, I'll get rid of my dummy data here. I'll actually comment it out so that we still have it for reference. But I'll set posts to an empty array now. And this is an empty array. And if it is empty, well, then we actually don't render anything. Maybe we want to show a placeholder, and we can use another structural directive for that. So back in the HTML template, we could say we only want to render this accordion here with all these posts if we got posts. So what I can do is I can check with another structural directive, which with ngIf, if a certain condition is true. And only if it is true, only then this part on which ngIf sits and all the child components will be rendered. And that's important. It's not hidden if it's not true. It's not part of the DOM. It will only be added to the DOM if this condition is true. And what is the condition? Anything you'll want. So you can refer to a function here which returns true or false, to a property that stores true or false, or write a short code snippet. Here I'll check if post's length is greater than 0. And if it's not, then this will not be rendered. In that case, I want to render something else. I want to render a paragraph where I say no posts added yet, lowercase p, and I will add ngIf to that too. And here I will check if posts length is smaller or equal to 0, then I will render this fallback text. And this is why we see no posts added yet here. Now this clearly looks super ugly. Thankfully, we can change this with some built-in CSS classes. You can find more under guides. And they're using Angular Materials typography. Here are some classes you can add. And there I will add body1 as a class. Here, mat, that's always appended at the, or added at the beginning, mat-body1. And now if we save that, we got a nicer look. Now it has the Roboto font, for example. And if we want to center this, for example, well, then we can also add another class, because I don't want to style all paragraphs. I just want to style this paragraph. So this will be my info text. And I will target this now in my CSS file, info text, and simply set text align here to center. And now we're using some structural directives to present a nice user interface. Time to be able to finally add some posts and connect the post create component with the post list component. So it would be nice if we could add posts, right? And to be able to do so, we first of all need to add one more input field to our, post create component. Right now we only got the text area. I will actually add one additional one, mat form field here. And in there, I'll add a normal input for the title. Now important, to turn this into a material input field, we have to add mat input. And this now, well, as I said, should give me the title I want to add. So here I will, for now, also use two-way binding. I'll rename this to entered content, and I will have the entered title 2. We can also get rid of new post, also down there. Maybe swap position steer to have the title first. Go back to the template and use entered content here, and on the first input use ng-model and two-way binding to bind this to the entered title. So now this is all up to date. Now we can create a new post in onAddPost, store it in a constant because we're not changing it. A new JavaScript object where we have a title property and where we store the entered title, and where we have the content property to store the entered content. And we can also structure this over multiple lines to make it a bit easier to read, I guess. Now, the thing is, this post is here. That's cool. How do we get it into the other component? We can use this property and event binding thing you learned about with the click listener and so on. We can use that on our own components too. We can emit our own events, and we can also send data into a component. And we want to emit an event here in post create. We want to emit an, hey, I got a new post event. And we want to listen to that event in the app component, which is where we were using the post create. We then want to get the created post, add it to a posts array, which we probably manage in the app component then later, and pass that posts array down to app post list. So step by step, let's first of all go to the post create component and emit our own event. To emit an own event, we need a feature provided by Angular Core, the event emitter. Then we add a new property, and that property here can have any name you want. So I'll name it post created. It makes sense to kind of use your event name as a property name here. And that will be a new event emitter created with the new keyword. And now with that, we can go to onAddPost and call this post created, and then emit, to emit a new event. Now here, we want to pass our post as an argument. That's important. So this passes the post as an argument. Cool. So how can we listen to that? Well, we first of all have to make Angular aware that post created is an event to which you can listen from the outside. Whilst it makes sense to be able to do that because you rarely want to listen to events you emit in the same component, you still have to do this explicitly. And you do this by adding a decorator to this property. This decorator is called output. So just like you added add component to the class here, you now add output, and don't forget the parentheses, to post created. This turns this into an event to which you can listen to from the outside. And from the outside means in the parent component. So in the component where you're using the selector. There, we can now use event binding to listen to post created. And then again, execute any code we want whenever this event occurs. And of course, what I want to do here is I want to get that post and store it in a list of posts. So in the app component here, I'll override title here with a new posts property, which is an empty array initially. But then here, I'll add onPost added as a method, as a function, so to say. And we know that we will get a post as an argument here. And it will therefore set this post or call this post and call push here and push this new post on this list to store it there. Now that's one part. Now we're adding this post here. Of course, this doesn't do that much. We also need to be able to pass this post down. But first of all, let's connect post created with on post added. So the method name you chose here. And to pass on the data you're getting, you have to use a special variable name, and that is $event. This essentially gives you access to the data you emitted. And that's not just for custom events, that would be the same for click events or any built-in events too. There you also get a default DOM event object. Whatever you're passing or receiving with an event, you get access with the special $event variable so that you can pass it on to your own method or use it in an inline code statement you might have here. So now we're passing this on. Now we need to pass it down to app post list. And there we can dive in. We got our posts. All we have to do is make the posts property bindable from outside via property binding. By default, it's not bindable, but we can make it bindable by adding a decorator to it. And since we had add output for emitting an event, it probably makes sense that here we use input. And this is added with the add sign and then the name of the decorator, input, and don't forget the parentheses. Now you can bind to posts from the outside, and from the outside again means from the parent component. Only from there, only from the direct parent. So here we add square brackets for property binding, posts, and we can set this equal to posts here. Now to avoid confusion about the names, I'll actually rename this here. I'll name this stored posts. So stored posts is the new name, and I will pass this on here. And now the chain is as following. We're listening to the post created event. We're adding the post in on post added to our stored posts list. And we're passing down that list, that array, to app post list. And Angular's change detection will automatically detect whenever a new post is created, when that changes, and when it needs to render this new post. So with this, we should have a complete chain in place that actually allows us to enter a title here and some content here, click Save Post, and see that being added here. And of course, we can add another title and even more content and continue creating new posts. So that's pretty amazing. This is how we can create our posts here and how we can add them with the help of property and event binding on our own components. We got that working chain where we add new posts and output it here. Now it's time to make our first little optimization. As you might have seen, we are using posts in different places. We got our list of stored posts here in the app component. We're outputting posts obviously in the post list component, and we're creating posts here. Now we ensure that they always have the same structure, title, content. We do this when we create them, and we rely on this structure when outputting them. We're referring to post title, post content. So a mistake in the creation would not be that good. Additionally, here in the app component, we actually just say we have an array. We could store anything in here. We could store numbers in here. And of course, we are writing our application. We probably don't mess up on purpose. But if we're working in a team or if we're coming back to that application after some weeks or months, we might have a hard time figuring out immediately which kind of data we stored there. Was it post.content or post.description? So it makes sense to create some models. So basically blueprints, contracts, which define how a post looks like in our Angular application. And I'll do that in my posts folder. I'll add a new file in there, not a folder, just a file. And I'll name this post.model.ts. So it's a TypeScript file, and in there, I'll use another TypeScript feature, a so-called interface. An interface is like a class that defines how an object looks like, but it can't be instantiated. It's more like a contract. We can use it to create our own type, to force a certain object to look like this, even though we can't directly create it based on the interface. And here I'll name this post. Now, We create it like that, and in there, what we can do is we can now define the fields and methods this should have. And I want to have a field title, which should be of type string, assigned with a colon. And I want to have another field content, which should also be a string. And this ensures that we got a clear definition of how a post looks like in our application. Now, of course, an interface in this file isn't that useful, so I add export to make it available outside of this file too. And now we can import this in all the files where we're using this. So in the app component, for example, we can now add an import post from, and then simply go to posts and import it from that post model file without the extension as always. And now we can say that stored posts is an array of posts by adding a colon here and then post square brackets. This is TypeScript syntax for saying we got an array of posts in there. And now if we would try to add a free, we actually get an error that a free is not a post. So this is pretty cool. We get a warning here. We would also get a warning if we try to save this and compile this. Of course, we got other places where we use the post too. In the post list here, we got another list of posts. So here it's the same thing. We import post from, go up one level, post model, and then assign a type here and say we got a list of posts. And finally, in the post create component, there too, I want to import my post type, so to say, from post model, post model like this. And then whenever we create a new post, this will actually be of type post. We can be very clear about this, and we can even be clear about the data we're going to emit. Event emitter is a so-called generic type, which simply means we can pass additional information about which type of data it works with. And the event emitter works with data in the sense of it emits data, and that data will be a post. So we can add lower than greater than signs. That is how you define such a generic type, post. Now we're saying data we emit will be a post. And now we're pretty safe, because now if we ever try to emit different data or do something else, we would get an error. And therefore now we can come back to that code and quickly see how a post looks like. It's also time for one other improvement. When creating posts, right now we're doing this with two-way binding. And it's not necessarily wrong, but Angular also makes it easy to work with forms. And of course it makes sense to also use a form semantically. So what we can do is we can add a form element, normal HTML element, in our card here in the post create component, and wrap the form fields and the button with it, like this. And unfortunately it removed my multi-line setup here. Let me recreate that. And now in here, I got my different inputs in that form. And now we don't need to use two-way binding anymore, though we can. We can use another mechanism Angular provides. When it detects a form element and we get the forms module included, which we do, it will automatically create a JavaScript object behind the scenes which represents this form, so to say, where we can easily register inputs as controls, of which it will keep track of, where it will then store the values of these controls, and where we can easily add validation to and submit the form and use the value of that form. For that, we can get rid of the two-way binding here with this syntax, and instead add ngModel like this, so as a directive without any bindings. This will register this input as a control to this behind-the-scenes form. However, Angular needs to know how to name this input, so we need to add the normal name attribute and give this any name of your choice. I'll name it title. And the same for the text area. We can use ngModel. We need to add a name now, so I will name this content. Maybe also reduce the rows, but that of course is optional. And now Angular is aware of these two controls on this form. Now, when we click the button, I don't want to call onAddPost manually anymore. Instead, I will set this button to be of type submit because we're now in a form, and the default HTML behavior is that a button with type submit in a form will submit that form. And submitting will trigger a special event to which we can listen to, the submit event, and that is where I want to execute onAddPost, like this. Now onAddPost, remember, is our method here. So now we're doing this whenever we're submitting the form, and Angular will also prevent the default, which would be that the form gets sent to the server. We don't want to do that. We want to handle this entirely in JavaScript. Now, with that, we get the form here. Now we need to get access to the values inside of that form. And this can be done with the help of a local reference. We can add a reference to the form, and you can name this however you want, like post form. And now important, you don't just add it like this. This would give us access to the HTML element object. We can actually assign a value here, and that value has to be ngForm. Now, that is a directive Angular implicitly attaches to the form element here for us. And what this strange syntax does is it gives us access to this object, this form object Angular created for us and manages for us behind the scenes. So now post form gives us access to that Angular form object, and we can pass post form as an argument to onAddPost. And in onAddPost, we now know that we received the form, which actually is of type ngForm, which you automatically, or which you import, my IDE does it automatically, from @AngularForms. So @AngularForms, this gives us access to ngForm. And this now actually holds a lot of information about the form. For example, whether it's valid or not. But it also gives us access to the values of the form. On the form, there is a value property, and on that value property, we can access things like title. So essentially, the names we defined here, title and content. So form value title gives us the title the user entered. Form value content gives us the content. Obviously, now it's possible to enter invalid content. We can submit an empty form, and we add an empty post, therefore. Clearly not what we want. We can easily add validation by adding some default HTML5 validators to our inputs. So this is not Angular. There is a required validator, for example. Now what Angular will do, though, is it will automatically detect this and then run some behind-the-scenes logic in JavaScript to also update its form object to reflect whether it's valid or not. So if it fulfills our HTML5 validators. So I will require both. You could add more. For example, there also is a min length validator where you could say the minimum length of a title is 3 and not just 1 as it is with required. These are things you can add. Now we got the validators in place, and now Angular is aware of the fact whether the form is valid or not. That being said, whilst this is the case, we can still submit an invalid form. If I hit Save Post, you see it actually marks them as invalid by underlining them in red. That's the Angular material feature, but it still submits it. If we want to prevent that, we have to do it manually. In onAddPost, we can check if form invalid, and if this is true, then we just return. What this means is that now if I reload and I click the button, no post is added, but it still tried to submit it, but now it marks it as red. And now thanks to Angular Material, we can also easily add beautiful error messages. If we go back to Angular Material and there to the form field, there on the right, you can click on error messages. And you see there's a special mat error component you can add below the input. Let's copy that into our post create component input here. So below the input, I add this, and we don't want to check email here there. We want to get access to that input. More on that in a second. But we can check whether this is invalid, and then, well, display an error message. We'll also have to change that. So what we can do here is, first of all, we need to get access to that input, and there are two ways of doing so. We can reach out to our post form and there call getControl, then pass the name between quotation marks and get access to the control like this. Or we add a local reference to that input, any name you want, like title, and set this equal to ngModel. So where ngForm gave you access to the entire form, diffs gives you access to the, well, data managed for that input behind the scenes. And then you could also say title invalid because now this is the form control behind the scenes. Now, whatever you want to output here can be dynamic content, but it can also be some hard-coded text like, please enter a post title. Now I'll just copy that mad error and also paste it below my text area here. And on the text area, I will now also add a local reference, content equal to ngModel here too. And therefore here we check whether the content is invalid. And now with that, if I save that and go back to my application and I submit this, you see we got the error messages below the inputs too. This is really cool. If I do enter some valid information here, I can submit. So this is form handling with the help of Angular forms, so-called template-driven form to be very precise, because everything is inferred from within your template. There is an alternative to which I will come back later. So template-driven forms and a little help of the Angular material package when it comes to beautifully handle errors. Now, one thing I noticed is that I accidentally removed my margin here at the top because I set margin to auto. Well, of course, we can fix that by adding 1 rem here on the margin to top and bottom, actually, and then auto to left and right. That's a quick thing, and that's not the main thing I want to focus on here. Instead, what I want to focus on is how we get new posts from the post create component to the post list component here. Right now, we got this chain of property and event binding. We're emitting a new post here, and we're passing it to the parent component, and then we're passing it down to the post list component. And this clearly works, but I guess you can imagine that in bigger and bigger applications, this becomes more and more cumbersome because you got longer and longer chains of property and event binding to get an element from component A to B to C to D to E. And that is not really what you want to build typically. So it would be nice if we had an easier way of passing data around, or an alternative at least. And such an alternative, which we will use quite a bit throughout the course for other things too, is a service. A service is a class which you add to your Angular application, which you let inject by Angular into components. I'll come back to what inject means, and which is able to centralize some tasks and provide easy access to data from within different components without property and event binding. I will create a posts service in the posts folder by creating a new file, posts.service.ts. And that name is up to you, but the convention is to name it .service.ts. Now, a service is just a TypeScript class. So I export a class, posts service, just like that. Now in there, I want to store a list of posts. So I'll add posts and set the type to post array. Now for this, I need to import my post model. So I import post from /post model like that. And this array initially is empty, let's say. You could also set it to undefined, but I'll set it to empty. Now here, I actually want to turn this into a private property, which means you can't edit it from outside. I do this by adding private in front of posts. Now, this post service, if we add it to another file, can't access posts. Instead, I will create a new method, getPosts, which allows someone who's interested to retrieve the posts. So in here, I will return this posts. I can do this because now I'm accessing the post from inside. But I actually don't want to return the original array because, as you might know, arrays and objects in JavaScript and also in TypeScript are reference types. And if you don't know what reference types and primitives are, an article and a video I created can be found in the last lecture of this module. It's really useful for understanding this. Essentially, a reference type is a type where if you copy it, you don't really copy it. The object in memory will stay the same, you just copied the address, so the pointer pointing at that object. So to make a true copy of the posts, I will use a TypeScript and next-gen JavaScript feature called the spread operator. I add square brackets to create a new array, and then 3 dots to take all the elements of another array, the posts array here, pull them out of that array and add them to this new array. So I'm creating a new array with the older objects, and therefore this array has been copied. Important, not the objects, these are still the old objects, but at least the array is copied. So if I now edit this array, if I add new elements or remove elements from within another component, this will not work, this will not affect my original array here. So that's a little bonus, you don't have to do that, but it's a good practice to do that, to try to be immutable, be clear about the fact that you don't want people to directly edit this posts array. And with that, we get a getPosts method. Getting posts is nice, but posting them would also be nice, right? So I will also add an addPost method where I expect to get a post as an argument. You could also just get a title and some content and then construct a post here, whatever you prefer. I will do the latter, so I will create a new post here. A post is of type post and it's a JavaScript object, which has to have, a title because that's defined in our post model. And I will store the title there. And a content property into which I will store the content argument. And now we can reach out to our post here or to our posts array and push the new post into it. Now, if we do that, we added this post and now we got methods for getting all posts and for adding a new post. Now we could use that from both the post list component and the post create component without having to pass data around with property and event binding. For this, we just need to get the service into these components. And this is done with a feature called dependency injection. Now this means that you simply go to the component where you want to use that, let's say to the post list component, and you add a constructor. You do this with the constructor keyword. The constructor simply is a function which is called whenever Angular creates a new instance of this component. And here you can expect arguments, but since Angular is the one creating new instances of the component, Angular has to give you these arguments. And Angular has a complex dependency injection system which is able to actually find out what you wanted and indeed give you that. So here what you do is you define the service you want to have, and I simply add an argument with any name you want. I'll name it posts service though, because that is what I want to have. And now you have to define the type here to give Angular a hint about what it actually should give you. So here I'll set the type to posts service, and I need to import this. So I'll go up there and import posts service from posts.service like that. Now this will actually tell Angular, hey, I want to have a post service instance because you set the type, and Angular will try its best to give you an instance of the service. However, I also want to store this in a property of my class here. So I can add a new property here, which I can also name posts service, which is of type posts service and is empty at the beginning. And then here we can set this posts service equal to the post service instance I'm getting here. Now, this is a bit of cumbersome. TypeScript offers a shortcut for this. We can omit all that code and actually get the exact same result by adding a keyword in front of post service. The public keyword will automatically create a new property in this component and store the incoming value in that property. Now that's all nice, and Angular will try to fulfill this requirement, but actually it won't be aware of the post service because it doesn't scan all your files. So you have to make Angular aware, and there are two ways of doing that. You can go to app module and add the posts service there, not in declarations and not in imports, but in the providers array. Providers are for services. There you could simply add posts service and also add the import pointing to that file. And then this would allow Angular to find that service. Now that's option number one, and there's nothing wrong with it. You can also take an even easier route and go to the post service and add an argument to it at injectable, which is imported from @Angular core. Don't forget the parentheses, and there you don't have to, but you can pass a JavaScript object to configure this, and you can then set provided in and set this to a string named root or with the content of root. And make sure to not mistype, root is important. And this simply will do the same. It provides this on the root level. And this not only means that Angular finds this also means, and the same was true if you added it to providers, that Angular doesn't only find it, but that it will only create one instance of this service for the entire app. So wherever you inject this, you're going to use the same instance. And this is really important because since we manage our posts array in the service, having multiple instances would be bad because we would have multiple copies with different arrays in there. Now we have one and the same instance, and we got it injected into post list, and there we got our posts service. Now all we need to do is call get posts. Let's do that and wire up the rest in the next lectures. So time to reach out to our service and call get posts. And for this, I will not actually use the constructor, though that would be possible, but it's a better practice to use a special lifecycle hook Angular provides. There are lifecycle hooks which Angular will automatically execute when it creates a component, and one of them is the onInit lifecycle hook. We add it by implementing an interface. This is essentially a contract this class now signs. It's called onInit, and it's imported from @Angular core. And this implementation now actually causes an error because now we're required to add a special method to our class here, the ng-onInit method. And once we add this, everything is great again. So now ng-onInit, this is a function Angular will automatically execute for us when it creates this component. And it's recommended to do basic initialization tasks in ng-onInit. And there I can now set this posts equal to this posts service. Remember, this automatically created a property of the same name. And there, get posts like this. Now we fetch all the posts. Of course, our posts are empty at the beginning though, so we'll need to add posts. And for this, we can go to post create. And there, I also want to connect to my service. So I'll add my constructor here too. Use the shortcut to automatically create a property named posts service and add the type post service. Import is added automatically by my IDE. Don't forget these curly braces. And now posts service is injected here too. Now here I want to reach out to the post service not in ng-onInit, but when I created a new post. So here I will actually remove add-output. I don't need it anymore. Don't need the whole event emitter anymore. Remove both imports. And instead of emitting, I will now simply call this posts service add post and pass my post there, or we're actually expecting a title and a string and a content. So I can also just pass these values here, title and content as arguments. I don't even need to construct the post in this file therefore. So this means we can get rid of the post import here too. So now we're calling add post from within the post create component. And we're calling get posts from within the post list component. And in the post service, we're connecting this. Let's give this a try. If I enter something here and I click save post, nothing happens. And what's wrong here? Now what's wrong is that we're getting posts when the post list component is created with ng-onInit, and at this point of time, we got an empty list there, right? It's an empty list of posts. When we later add posts, this doesn't do anything because we created a copy of posts and returned that. So if we added the original array thereafter, this doesn't, well, affect anything on our post list component. By the way, we can also remove input here. So this is the reason why it's not working, because we fetched the posts, a copy of them, before we added them. Now, there are a couple of ways of solving that. We could not fetch a copy, for example. If we do that, you will see that now if this reloads, I get an error, right? Because I should go to my app component HTML file and remove the bindings here. We don't need that anymore to manage our posts. Let's also remove it in the TypeScript file of the app component and remove the post import. So let's save all that. So now if I go back, it loads again. And if I now enter something here, you see the posts are added again. But this is not the cleanest way of doing that. I'm a fan of copying this to avoid unwanted manipulation of the posts in any component which is fetching our posts. So a better way is to use an event-driven approach where we actively push the information about new posts being available to the components which are interested. And for that, we could use the event emitter, but the event emitter is really meant to be used in conjunction with that add-output decorator. Instead, I'll use a feature provided by another package, which is not part of Angular, but a core dependency, the RxJS package. You find it here. It's installed from the beginning. RxJS is all about observables, and this is a concept which can be a bit more complex to grasp. It's essentially about objects that help us pass data around, you could say. And we'll dive deeper into observables step by step, and I also dive deeper into them in my complete guide on Angular here on Udemy, and also a complete YouTube series I got. So we simply need to import something from that RxJS package to get started. And that something is a subject. Now that essentially is an event emitter, you could say, but one which is actually for broader usage than the one Angular ships with. And now I will create this subject here as a private property too. I'll name this posts updated. Again, taking a property name here which sounds like an event. This is not required, but also not the worst idea. And I'll create a new instance of my subject, just as the event emitter. This is a generic type. And here I plan on passing a list of posts as a payload. So we get the posts updated subject here. And now when we have add post here, or when we call this, I don't just want to update my posts. I also thereafter want to take my subject, post updated, and there it's not emit, but next. And this pushes a new value. It emits a new value. And this value is a copy of my posts after I updated them. So this is now the subject. We can still leave get posts in there, even though it's not that useful right now, but that could change later on. What I now want to do is, of course, I want to be able to listen to that subject because it's emitting whenever we add a post. How do I listen to it? It's private, so we can't directly access it to prevent other components from emitting data with it. What I'll add is, I'll add a new method here, get post update listener. The name is up to you, of course. And there I will return this posts updated. And then there's a special method we can call as observable. And now it returns an object to which we can listen, but where we can't emit. We can still emit from inside this file, but not from files which received their reference with the help of this method. So now we got get post update listener. We can now go to the post list component again. And I will still fetch that list of posts at the beginning, even though it's guaranteed to be empty right now. But what I will also do is I will set up a listener to that subject. I do this by reaching out to this post service, get post update listener. This returns this observable, and there we can call subscribe. This is a method which is made available. Just putting this into a new line to make it easier to read. It still is part of this statement here. So subscribe now sets up a subscription, and subscribe actually takes 3 arguments, possible arguments. The first one is a function which gets executed whenever new data is emitted. The second argument will be called whenever an error is emitted. This will never happen here. And the third argument will be a function that is called whenever the observable is completed, whenever there are no more values to be expected. This will also never be the case here because this is an infinitely living subject, so to say. We can always create new posts. So we only add the first argument, a function which is called whenever a new value is received. And I'm using an arrow function here. We receive some data here, the posts, right? Because in the post service, we are emitting our new posts, a copy of them. So posts is what we receive. So I'll set the type to post array to be very clear about what we're getting here. And in here, I can then set this posts equal to the posts I just received to update them whenever this got a new value, received a new value. Now, one important thing, this subscription here actually doesn't cancel whenever this component is teared down. Now, right now, this component never disappears because we got only one page. We got no way of removing that component from the UI. But later we will. Later there will be more components, different pages. And we want to ensure that whenever this component is not part of the DOM, the subscriptions which we set up in it are also not living anymore. Otherwise, we create a memory leak. So we will actually store that subscription in a new property, which will be of type subscription. So I'll import subscription from RxJS like this. Here, subscription. And now I will create a new property here, private property maybe, it doesn't matter. Posts sub, which is of type subscription, and it's undefined at the beginning. And here in ng on init, I will set this posts sub equal to this post service and the subscription we're defining here. Now we just need to unsubscribe whenever this component is destroyed. And there is another lifecycle hook we can use for that. We add it by implementing onDestroy. This forces us to add one other method, the ng onDestroy method, which is called whenever this component is about to get removed. And there I will reach out to my posts sub, not the service, the sub, and call unsubscribe. And this will remove the subscription and prevent memory leaks. And with this added, if I go back, we can try this, add a post, does this work? And hit save post, and you see we can add new posts here, of course also with other content than the old one. And now this is working with the service. And whilst the setup is of course a bit more complex, it saves us a lot of time since we don't have to build these chains of property and event binding, and you already learned quite a bit about observables here with this event emitter we're using here. So now let's move on. In the last lectures, we learned about the subject, subscriptions, and this seems to be related to something called observables. Time for a closer look. So what's this observable thing? As you could probably tell by the code we wrote, it's all about us emitting data and listening to that data in different places of our application, which makes it pretty helpful because we can, well, subscribe to certain updates, changes, and push these changes from a totally different place. Here's more theory on that. So we typically think in observables and observers. The observer is essentially the thing subscribing to an observable, or the thing which establishes this subscription and manages it, you could say. There are three methods which are called on the observer's side, and that's next, error, and complete. Now, we called next on the subject in the last lectures, and the subject is kind of the observable, you could say, but it's the observer who then does something upon the next call in that subscription callback we passed, right? That first argument we passed to subscribe, that is the logic we want to execute whenever next is executed on the subject, so to say. So we invoke next through the observable or through the subject. I'll come to the difference. And the observer is what we basically pass into subscribe. So it's a collection of functions that can do something upon these method calls. And as I also explained briefly, we can not just emit next data, so a new package of data, so to say. We could also have an observable where we want to throw an error, maybe because we're doing some HTTP calls behind the scenes that failed. Or we could also emit a complete event to basically say, hey, I'm done, there are no more data packages to be emitted, so no more next calls. Now, a typical example, but of course not limited to that, is an observable that wraps a callback of an HTTP request. So we could wrap a normal XML HTTP request, an AJAX request, with an observable that basically takes that callback, and whenever that request gives us back a response, we instead use that observable to emit the response data or a possible error as a next or error message. And that is essentially what we could do. We could also complete the observable once the response is there, because of course If the response is there, this HTTP request will not yield any other responses. As I said, it could also fail. And that is how we could manage such a HTTP request. Now in our app, we didn't manage an HTTP request, though we managed a subject or our own event emitter therefore. Now a subject is really just a special kind of observable. A normal observable is kind of passive. You wrap a callback or an event source, like a click listener, with it. So you don't actively trigger when a new data package is emitted. That happens when your HTTP request gets a response or when the user clicks something. Instead, you just, set up this listener and then you can subscribe to it. A subject is more active. We also subscribe to a subject, but there we can manually call next. And that makes it a perfect event emitter because we can not just subscribe and wait for something which we can't directly influence. Instead, we can directly influence when a new data package is emitted. And that's exactly what we need in our application. When we add a new post, then we actively want to notify our entire application. And that is what we can do with a subject. So in general, you can think of observables and therefore also subjects as streams of data or of values. So we got one value and we can have more values which are emitted over time, depending on the observable and the data source it covers. Then we have the observer, so that's essentially this set of functions we can call next, error, and complete. And for a normal value, we typically would call next. And if we have an observable that wraps something like a HTTP request, then it would do that for us. And as I said, we can have more than one value over the course of our application. That depends on how we're using that observable. Eventually it may end, but of course there are also observables that may never end. For example, if you're wrapping a normal click listener with it, well, then this will typically never end. If you got an observable that ends, well, then the complete function here will be called. And this is how it works. This is how we work with observables, how we should think about them. If you want to learn way more about RxJS observables, in the last lecture of this module, you find a link to an in-depth series I created on YouTube, but that's the core mental model to wrap your head around for now. We will mostly use the subject. We will indirectly use some observables, and I will explain what they do when we use them. But in the end, think of it as a stream of data which you can actively manage in the case of a subject, or which is managed for you if you're wrapping some, source you can't directly influence. And then you can decide what you want to do when new data is emitted in your subscription. So now with this closer look at observables, let's finish up our form here on the Angular frontend and do some first polishing before we move to the backend and add Node so that we don't just have a frontend, but we also start working on the backend. So here's our frontend, our Angular app as we left it. It's far from being finished and we will revisit it later in the course. But for now, let's do some polishing. One polishing or one addition I want to do is, would be nice to have some labels here, right? And actually you can add labels easily to your forms in Angular material by going to the HTML code and adding a placeholder attribute. And there we could say title or maybe post title, and we can also add that to the text area and say post content there. And you will see that if you add such a placeholder, you get it as a label here, and you automatically got this floating label look here, which is quite neat. Now, one other thing I want to do is, if I enter a new post here, right now you can see the values stick around. This form doesn't get cleared. And we can clear it in onAddPost, where we get access to that form, by accessing form and then calling reset form like this. If we now save that, let's try this again. Let's enter something here. Let's click save post. And you see this now resets the form and also the validity, not just the values. It doesn't just clear the form, it also resets the validity, which of course is exactly the behavior we want. Now that's almost all. One other thing I want to add for now already is I want to add an action bar to the post. Whilst the functionality is missing right now, we will add it later, I want to be able to edit and delete such posts. Again, the logic behind that and the code will be added later. That means I want to have an edit and a delete button here on this expand panel or on this expansion panel. If we check the official docs, we can see that there is an action bar or an action row component we can nest into our expansion panel. And that looks pretty promising. With that code copied, if we go back to the post list component here, we can add that below the paragraph in the expansion panel, and we get a button here in the code snippet 2, and it will simply say edit. I will actually add 2 buttons because I also want to have a delete button here. You can also make this all caps to be closer to the original material style, by the way, where buttons tend to be all capitalized. Now, the buttons, if we add them like this, can be seen. Let's quickly add a post here. Here are the buttons, but they're not looking that spectacular. To make them look a bit more spectacular, what I will do is I will add some colors. For the edit button, I'll assign my primary color, or maybe the accent color, whichever one you prefer. And the delete button, here I will use my worn color, because people should certainly be careful when clicking these buttons, or this button specifically. So now with that added, if we add one more post, we see edit and delete. Now, since my accent color is this pink color, it looks very much like the delete button, so I will go for primary here to have a greater difference between the colors. So let's add one more post here. Yeah, that looks better. And that is the last thing I wanted to prepare. Now again, we will improve this code a lot later. We will add an edit and delete functionality. We will also add more components, more pages on our front end. But for now, it's enough about Angular. Let's move on to the backend. Let's move on to Node and understand how that works and fits into our Angular application.